So today we are going to design a Arduino development board using Atmega 328P. Have you designed any have you used Arduino boards in your college days?
Yes, ma'am.
Yeah. You have seen right how the Arduino looks. What are the subunits of Arduino?
Yes.
Okay. So then we will directly going to design that schematic of that Arduino Uno, which is made up of an Atmega 328P microcontroller. So let me name my Arduino project as Arduino Development Board. Making use of Atmega 328P. Let me briefly show how the subunits of Arduino looks. This is the Arduino Development Board, which has one input DC jack. This is the DC jack,
Ma'am,
and this
screen is not visible.
sorry, I forgot to share the screen. Is it visible?
Yes, ma'am.
Okay. So can you see this Arduino board?
Yes.
Okay. So in case of Arduino development board, this is the DC jack where you will be providing a DC input of from ranging from 5 to 12 volts, and this is your 328P Atmega 328P IC, and it will be having some digital pins and some analog pins, and it also has some FTDI pins. These are the FTDI pins, and also it has a reset pin and inbuilt LED. So we will not be designing all the subunits, but we will design some of the important subunits like digital and analog pins, FTDI pins, and this Atmega 328P and the DC jack. So let me start with the schematic. As I already designed my DC input unit, so I will be copying that from my previous design. This is the power supply unit which we have designed for our IR sensor. So you can copy this. Just select that unit and press Ctrl C and go to your present schematic and paste it. You can drag wherever you want and place that. This is my power supply unit, and I need this analog and digital pins. There will be 14 digital pins and 6 analog pins. So these are the header files. They're not header files. These are the headers that are female headers. So we will select the headers from my e-library. This is the header of size like 0 to 7 and 8 to more than 13 are there. So I will select from 1 cross 8 for the digital pins because I have 18, like 14 digital pins, and I left with 6 more digital pins. So I select 1 cross 6 here, and I have analog pins, 6 analog pins. And you need to connect a wire for that. So you need to connect these wires to your 878 like Atmega 328P IC. For that, we will make use of the net flags. Now you can use this net flags to name this. First one will be my D0, that is digital pin 0. Press enter, and when you select one more red flag, it will automatically reset it. It will be incremented. If you have written D0, it will be like D1, and again it will be incremented to D2. It will be D5, D6, and D7. And make sure that this plus sign is placed on the wire properly. And I left with 6 more digital pins. I will place it here. This is my D8, D9, D10, D11, D12, and D13. And I have analog pins. So for that I will select this net flag again and rename it as A0. A1, A2, A3, and A4, A5. So we are done with the header, that are the main headers. So I can place a box here. And make it as -1. For that you need to go to the right corner where you will find other options called dashed and dotted. So select the dash option, and now I will design a reset circuit. In your Arduino Uno, you will be having a button where you can reset the whole circuit so that the Arduino will be resetted and you can dump your programs there. For that, I need a resistor. Should be axial resistor, and I need a diode. So part name of diode is 1N4007. So you need to select the second option here. It is placed in parallel fashion with the resistor. Again, for this, I am going to connect a inbuilt LED. So for that, I need a resistor and LED. In Arduino, pin 13 will be connected to a inbuilt LED. Firstly, I need to connect a push button. So I need to go to library and search for push button.
Ma'am, where is the schematic of it?
You will find it in online. You
Means
need to search for the
we are
schematic.
we are making it without seeing any schematic.
No, no, no. I am seeing this. You can search for the schematics here. Schematics of Arduino. And these are the schematics. They have used many like EDA tools, Eagle and all, and their designs are somewhat different according to whatever subunits they have taken. For me, I have chosen that FTDI analog pins, digital pins, reset button, and power supply units. I need a push button here. So this is a SMD push button. I have to select through component. You can select this one, or if you find something which is better than this, you can go through that. The push button should have footprint, not only the symbol. You will find a push button with 2 pins and 4 pins. You have to select the 2 pin push button, and you can select this and place it here. This has to be connected to my VCC. This is my VCC where I am getting an DC power supply. So that has to be connected here. And this is my reset pin. Again, select the net flag and rename it as a reset. And one terminal is connected to VCC. To get the symbol of VCC, search in this wire tool. You have an option called VCC there. You can connect that. And you need to connect one more VCC here. that this VCC and this VCC will be internally connected. And this terminal is connected to ground. This is connected to VCC again. This is my reset pin. These both reset pins will be connected to my ATmega 328P. And to get the ATmega 328P, you need to go for global library and search for ATmega 328P. This is the one which I have made. You can go for system or LCSC. Select the one with the through hole component. These red parts indicate the SMD component. And even in this rectangle box, they have mentioned it as SMT. If you don't know how the ATmega 328P looks, you can search for that. So this is the 328. Go through the specifications of this IC. It has 28 pins, 14 on each side. So this is the through hole component and this is a SMD component. I need to select that one. You can select this and place it. Just see whether it has proper pins or not. So it has 28 pins starting from 1. This reset has to be connected to this reset pin. Make sure that you are giving the same name there using net flag. And this is the RXD and TXD transfer and receiver pins. It has TX and RX. This is my RXD. To that I will be connecting TX. This is my TXD. For that I will be connecting RX. And these two pins are again connected to digital pins. You can see this pin indicates PD0 and PD1. These two pins have multi-functions. They can act as a receiver and transfer pins, and also the two digital pins D0 and D1. It has to be D0 and it is D1. And for this 9th and 10th, I need to connect a crystal oscillator. A 16 megahertz crystal oscillator has to be connected. For that, you can search the crystal oscillator of 16 megahertz. This is the 2-pin crystal oscillator. You can select that. First pin has to be on upper side. We are connecting two capacitors here to remove the noise. The capacitors are of 22 picofarads. And this has to be connected to ground. This is my VCC. My power supply has to be connected here in this VCC. So you can select a VCC symbol here. Connect that to your 7th pin. Again, 20 and ARF also has to be connected to your VCC pin. And these two are shorted and connected to ground pin. This ADC0 indicates an analog pin. Your analog pins has to be connected to these pins. Again, you can make use of the net flags. Starting from A0. Again, the pins will get incremented automatically. You can connect directly them. And these are the digital pins. You have already connected D0 and D1 here. So we will start with the D2. This is my D2. D3, D4, D5, D6 and D7. And rest of the digital pins are connected here. So D8, D9, D10, D11, D12 and D13. So this is the connection of 8 ATmega 328P. And now we are left with the FTDI connection. Again, we will take a header with 6 pins and rotate this by doing horizontal flip. For the connections, you can refer to the Arduino Uno schematics. So these two pins are connected to ground. And third pin is connected to VCC. And fourth and fifth are my transfer and receiver pins. You can connect a resistor here to avoid the damages. And this is my TX pin. Whatever name you have given here, the same name has to be given. This is my RX. Again, the sixth pin is connected to reset pin. And we can connect a small resistor, a small capacitor of 0.1 micro. And you have to rename it with reset pin. You can make an individual blocks for that. Again, do them dash one. I will provide the schematic view of this Arduino Uno. Try to design this schematic. अभी हाँ अपने पापा नहीं लेते ना हाँ अपने अले अतैले 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 करो You can rename them by using text. Arduino Development Board. Atmega. Rename the sheet as schematic. And save the schematic. We're done with the schematic. Again, you need to convert this schematic into layout. I want you guys to try this. I'm not going to do that. And this will be your last project, Arduino Development Board. I can show you how the layout has to be done. So you can do in this fashion where you have to place the Atmega 3280 IC at the middle, and you can place the analog and digital pins at the both the sides of that Atmega 3280 and connect all the other subunits. Or you can give the customized board like this. This is exactly looks like your Arduino Uno. You can give the customized shape for that. Or if you want to make it as simple, you can do a simple rectangular, or you can give a customized board outline. Is it clear?
Yes, ma'am.
Yeah, will you try this? I will provide the schematic of that. Try that and do the layout. Let me know if you find any difficulties in finding the footprints and finding the 3D models. When you complete all the activities, you will be like receiving your certificate.
Ma'am, do I need to submit this layout?
Yes, yes. You need to share your schematic and PCB PDF files. You can generate a PDF files by going to File and Export as a PDF. And you can save here.
Okay.
And if you want to
Ma'am, what is Jarbad files?
Gerber files, like if you are going to give your layout to your fabrication processes, you need to generate a Gerber file for that. It will be having all your layout specifications.
Done that. How to generate that?
Again, you need to go to this file and you have an option called generate PCB fabrication file. Okay, and it will check for your DRCs and all, and it will generate a Gerber file for that. If you have no errors, it will generate. So if you have an error, it will provide an error here. You can see this has a clearance error. If you do not like maintain a minimum distance, it will provide the errors. So let me try for this. Again, like you need to maintain some minimum distances and all. Then only you can generate your Gerber file. So if you are not going for fabrication processes, you just need to export your PDF or PNG format and you can save on your computers. Otherwise, the project will be saved in this software only.
Okay.
Okay. Do you have any doubts?
No.
Okay. Then try to complete the previous activities as well as the Arduino board. Let me know if you find any difficulties there.